What's up? It's Bowtie Friday. I'm Austin Griffith. I'm here with the Build Guild. We're building stuff. First up is Rostyslav. Rostyslav, take it away, man. What have you been working on?
Hey, hi guys. I've been continuing working on my project Slovo, so I finally finished it and the functionality actually works. So basic outline. What I'm doing is I'm gating the content, which is the PDF file, the book, behind the NFT access conditions. And for the backend to decrypt and encrypt, I'll use a lit protocol, which allows me to simultaneously encrypt the file, upload it to IPFS in encrypted form, so nobody can, steal your work. And then whoever buys the NFT will be able to access that book by downloading and decrypting it on their device. So I can make a little demonstration. So last time I showed the published book. I think I can skip it. Right now, I'm just going to show demonstration. So right now, this is all the books that I have currently published on the platform, for example, and I can purchase it like any other NFT. And
Go ahead and share your screen too. Yeah.
Is it sharing?
Not yet. Not yet.
Okay. Do it again. Yep.
There we go. We got
you can see it. So here, as you can see, last time I showed how to publish a book, so I think I can skip it right now, okay? Yeah, and now let's see, I'm gonna purchase a book and show the demonstration. So this is a regular NFT that you can buy, same standard. And then if I go to your library, it's gonna show up right here. So right now it's still, so unfortunately Girl is very slow and I could not use optimism because lit protocol does not, for certain chains, they don't allow the optimism, but for demonstration purposes. Okay, here it is, complete successfully. Now let's see, it's gonna pull up. And yeah, here's the Jordan book, and I'm gonna do the most important part, is to actually read the book. Oh no. Okay, so no, this one has the wrong IPFS ID. Okay, I'm gonna demonstrate with another book. Yeah, okay. So yeah, this is how it works. Pretty simple functionality. Sometimes, unfortunately, I still have to work out how to store the CID is the key for this decryption on either on on-chain or off-chain. But what I want to actually show is the code itself really quickly. So the most important part from all of this, as you can see, is the lit protocol. It was the most pain in the ass to actually make it work. But the general outline. So here I have access conditions, and this is a template access condition. Is the most important part is as long as you have more than one book, you get access to that book, meaning whenever you hit the decrypt. So decrypt will be this function. So decrypt function will grab the IPFS CID, which is the CID for that encrypted file on the IPFS, and then it will check with your what is called the signature if you actually have that NFT, and when you supply it to the decrypt from an IPFS function from the lit SDK. On the return, it will grab that file, decrypt it, and download it to your device. So this is the general outline. So with this, right now it's on the go early. So basically anyone can come in, upload any of their IPFS PDF file, put the name, put the description, the symbol they want, it will generate the NFT, and also they can upload the the cover for their book, and then the book itself, and then specify how much they want to for each book to get, and percentage of the royalties from ongoing resales. And I've seen the in NFT standard they added a new feature where you can add royalties that will not be tied to one platform, but will be possible to use to many platforms. So you can put whatever you want, and then if it's on OpenSea, if it's sold on OpenSea, or if it's sold on the Blur or any other NFT platform, you still will be able to get that the royalties from ongoing resales, from second market resales. So yeah, that's pretty much it, and I'm glad that it worked.
Cool stuff.
Any questions?
Lit is about encryption and key management, right? That's basically what they take care of for you. So it's not using your Ethereum key, it's using some session key, and then it's encrypting and decrypting with that, but they have custody of the key somehow, and it's
yes. So for that, they they do and they don't. So they use, it's called what it's called. It's kind of they don't hold one key. So basically what they do, they have a bunch of nodes and they spread those keys to many nodes, and you just only need 66% of those keys to decrypt the file. So it creates a redundancy. So if one of the nodes are down, you're still able to decrypt, encrypt, use the lit protocol, and they no one node holds the key, so there is no a point of failure where somebody can go and steal the key, and they will be they will have to take over the majority of the network, not even the majority, the 66% and more of the network, in order to steal your encryption keys.
Got it. Awesome. Okay, nice build, Rostyslav. Cool stuff. Next up is Quizford. Quizford, what do you got for us? What'd you build? Are you out there, Quizford?
I hope you can hear me.
Yep, we got you.
All right, let me start sharing.
McToady's up next after Quizford.
Is this working? Can you see
Yeah,
me?
looks like golf.
Alrighty, sweet. Yeah, so when I first bought my first NFTs, I kind of stumbled upon the fact that I didn't understand the contracts, obviously. And so basically, over the past year, I've kind of learned how to read a contract, compile a contract, and kind of write a contract. So within the game, it kind of goes through multiple steps, brings you along multiple different links, including the speed run and everything, and teaches you how to use Etherscan, block explorers, Solidity by example, how gas works, how to read opcode, basically a little bit, just so if somebody's interested, they can get an understanding of how the contracts work and how to actually kind of figure them out if you wanted to. And as a little game component, it's built in a little golf game where you kind of pay entry fee. It's sitting on Zapolia right now, so it's a little bit slow, I guess, on the home network. It actually works a lot faster, of course. And so with every challenge, you kind of go in, you find little clues, little numbers, you add them up, and you make the shots once you have it figured out. And in the end, if everything works out, you have a scoring that will allow you to put your name in the Hall of Fame, so to say. And so on the main page, you have a little list of everybody that played and everybody that managed to get the right shots with the right amount of ETH. So you basically, let's say I will make a 11er shot.
Looks like Zach's golf score, an 11.
You sign the transaction, and it just keeps count of each of the players. So multiple players obviously can play at the same time. And yeah, I mean, it's basically just a rundown of how to read a contract, how to kind of decipher a contract, and brings you along the whole EVM journey, showing you kind of what the Ethereum community is about, contract safety and security, and that's basically it.
Awesome. Cool build. So it's a build with Scaffold-Eth that takes you through the speed run, but kind of gamifies the whole process. And it's not just the speed run, you're looking at Etherscan and lots of other things, but it kind of gamifies the onboarding process and the learning process.
Exactly. So there is I have a repo that it's a putt game first that was basically in the style of the speed run, where you have to install Scaffold-Eth 2 and run it on localhost. And then, ended up building a version that's playable online, basically.
Fun. That's awesome. Cool. Make sure you share that link so we can share it in the notes too for other people that are looking for a more gamified experience of getting onboarded.
All righty.
All right. Next up is McToady. Good build Quizford. I always love seeing educational stuff. Oh, we might need to steal a screen from you. There we go. All right, McToady's up. Probably doing something DeFi related. Nope, it's Ethernaut. It's Ethernaut thing.
Yeah,
right?
I'll carry on with the kind of educational gamified stuff.
Perfect.
If I can work out how to share my screen. Okay, we're in the game. Okay, so most of you probably know Ethernaut, the original, kind of the CTF for like security, Solidity, vulnerability kind of stuff. And yeah, it's great. Wax lyrical about it. I think it covers almost all of the key kind of vulnerabilities and like some quirks in Solidity or the EVM. But when it was made, it was a console. You did everything in the console using Web3 JS, not even Ethers. Like this is a long time ago for us old. I guess I'm an old head now. But yeah, so my issue with it is I believe kind of the Bruce Lee, the guy who practiced one kick 10,000 times is more feared than the guy who practiced 10,000 kicks once. So I think with something like Ethernaut, you should really be coming back to it every few months, even if you've already flew through it. And the web version doesn't really help with that, especially if you've already done the thing. You get this, you get like broken everything. You get a like completion things. You have to go all the way to, okay, get a new instance. Let me open up the terminal, copy this, paste this. It takes a while. So what I've tried to do is I wanted to make, where's Visual Studio Code? I wanted to put everything into one repo where you can just pull this straight off of GitHub and you can solve everything without ever needing to go to the website at all. So I've got all the contracts are in here. I'm slowly bringing in your faces are in the way, guys. One sec. I'm slowly bringing in all of some of the info and adding some more to it too. As you can see here, like this is the description they give you, as well as some resources if you need to help out. But yeah, so instead of that, you can just do it like this. And the build itself, pretty simple, really, just like kind of standing on the shoulders of the existing Ethernaut and Foundry, which is probably the go-to security environment, whatever you want to call it, for nerds such as myself.
And then VM or Ethers?
Oh, no, all Solidity.
All Solidity. Awesome.
We're full freaks. Cool. There's no everything's Solidity. So yeah, I think I've pre-answered this one just so we can show how it works. But yeah, you can, at least how I've played with it, you can spread yourself out like this, where you've got the contract up here, you got the information down here, and then you've got your script to solve. And then when you're done, you just have to jump into a terminal. I've already done this to test because I don't want to show you guys my typo skills. But yeah, so you just run yourself a script. And if this fails now, I'm going to be so sad. And then we're going to be successful. Yeah, there we go. Passed. We're superstars. But yeah, as for the build, yeah, pretty simple. The only weird thing was, for reasons unbeknownst to myself, the functions in the Ethernaut contract when you create a level instance, doesn't return the address of the created thing. So we have to do a little bit of event capturing. So yeah, we have to search for this event to get our instance address, rather than, yeah, if it just returned it, it would be so much easier. But, and then the same for the, when you submit, it doesn't say like, true, you've passed, or false, you screwed up. So yeah, you have to, there's a little bit of funny stuff going on in the background, but I've managed to abstract that all away into here. So your script itself remains pretty bare bones. I think it comes to you like this, no interface. So yeah, doesn't get in the way, shouldn't be too daunting to like look at a big ball of text. And yeah, we just do a little bit of funky stuff in the background in a different file. But yeah, that's it. I just, everyone should do this all the time. Every few months, you should be doing Ethernaut.
Very cool.
Yes.
Make sure you share. So this is just going to be a repo that anybody can fork. And once they fork it down locally, they can just basically run through the whole Ethernaut, but on localhost using just Foundry. Is that right?
Mm-hmm.
That's awesome.
So yeah, it should work well. I'll post a link to the GitHub in the chat shortly afterwards.
Perfect. Good stuff.
Okay, good stop. Okay, cool.
The Ethernaut is still like actively helping with so many retro PGF stuff, and the Ethernaut itself. I'm thinking of the dude Alejandro, but the Ethernaut itself as a tool is still so powerful and good. If you haven't done it, you definitely should. And here's an opportunity to do it on localhost, so you don't have to wait for Sepolia or whatever the test net is. Okay, next up is Damu. What you got for us, Damu?
Hi. I will share the screen. 1 second.
And then Coderxyz next.
I have today 2 builds to show off.
He's gonna take all our money again. He's gonna have us all
of course. Can you see my screen now?
Yeah, we've got it.
Okay, this is the dice random game that it was migrated from the old Scaffold-Eth to the new Scaffold-Eth 2. This is a simple game that is like a way to test this randomness from the RANDAO after the proof of stake from Ethereum. Now we have a source of randomness from the blockchain. This is a hash that all the block proposer set in a good way. Each block proposer only only set 1 bit. So this random hash is hard to attack. And this game, you have to bet a number between 0 and 15. And the way that it works is the random number that the dice roll is determined is get from a future block from this random source. So you have to wait some blocks to be able to roll the dice, and then you get this random from this block. And this is the bet is done, and here will appear the. I think that I have to wait because I have to wait 2 blocks. But
A bunch of us have bet too. Your bets would be updated if you hit reload. I'm not sure if that would mess anything else up.
Okay, I will roll the dice and see what happens.
So randomness is super hard in Ethereum. Most folks on this call have probably gone through the dice challenge and messed with how a lot of NFT mints just use like a block hash, right? Like the current block hash. And with the dice challenge and all the way back to the Ethernaut, there's a randomness challenge that basically sets you up so you create a contract that can predict or just check and see if it's going to win or not, and only gamble if it's going to win. And so this idea of future block hash is another good way to do it. But what you're doing here is you're mixing with the block difficulty, which I think is what you were saying is each proposer gets to have one bit of this block difficulty. And this block difficulty is like this big mixture of randomness from all of these validators.
Yes,
And
this difficulty header field that before the proof of stake merge was used for the block difficulty. Now it's used for this random hash.
but the random hash is still like predictable within the same block. So you've got to say, you know, block
Yeah.
10
Yeah, or maybe
blocks
you
in
can-
the future.
Yeah, or maybe if you use the randomness from this same block, you can revert the transaction if this random is not good for you. So you have to use a future block to be able to can revert an action if it's not good for you. And the way to that this works is when you have the future block that you commit to use this random from this block, you have to get the block header from this block, and you have to this is all the you are seeing my code. Are you seeing my?
Yeah, we're seeing the repo.
GitHub.
We're seeing the top
Yep.
of the repo right now.
Oh, I will share the code. 1 second. Now, yes.
Yep, we've got code.
Okay. So you have to get the block from the block that you will get the random number, and you have to. This is for create all the block header info to be able to send this header to the contract. Here, I am encoding this header, and then when I call the roll the dice method, I send this header encode. So then the contract get this header block and check if the block number is the right one, and then get this difficulty that is from the random came, get the block number, and then it's calculate the hash from this header and compare with the block hash from the block number. If this is the same, that means that you are sending the right block header, and the contract can use the difficulty as a random source for anything. And well, only you can access only the block hash from the previous 256 blocks. So you have to try to not miss this window to check this random. Well, here in the front end, I when I calculate the header, I can calculate the hash from the header that I build and the real block hash, and check if the header is well formed.
So it's very tricky, right? It's
yeah.
using
And I
like
have a
future block difficulty And so there's this like commit and reveal almost like thing. And it's better than block hash because it's future block hash, but it's future block difficulty, which is even harder to tamper with. But to get that, you have to package up the whole header and get it to hash to the same thing as the block hash, because you can look up the block hash, but you can't look up the block difficulty. So you've got to construct the block header, get the block hash, make sure the block hash is right, and then use that block difficulty as your randomness. And that only is visible for 256 blocks. So if you wait too long, it completely disappears and you can't get your money. So it's a very tricky, very interesting way to get a very good randomness on chain, but comes with a lot of caveats.
Yeah, exactly. And I have a lot of trouble with this new withdrawal rods that is one introduced in the last Ford from Ethereum that I haven't, because this was working on the old Scaffold-Eth, but then I try again today and it doesn't work because without this new header, the block hash is wrong. So, well, I have to dig into the Ethereum coder to be able to know about this and how to add to the header.
You had to get into the
well,
Geth code base, right? You had to get into Geth
yeah.
and then look at the header and figure out how to
No,
calculate
again,
the header in
no,
Geth.
into the Ethereum no code.
Oh,
Yeah. But well, this is a nice way to get a truly on-chain random number.
with all the caveats of the 256 block window, the kind of commit reveal like double transaction that has to happen. There's a lot to make this block. Like you would have to be making like a lottery that's going to be like giving away millions of dollars to want to have to use this complicated method, or some like fancy game that you would have a lot of money on the line. Cool.
Yeah,
yep.
yeah. And
oh, it looks like there's a second thing. ENS,
yeah,
are you doing two presentations? Go for it.
Yeah, true. I built an ENS offchain resolver. You can build ENS resolver that is not on-chain, like mostly the one that mostly use. You can use off-chain, and you can like this Lugis ENS name. This is a custom resolver. This is a smart contract that I deploy. This is the contract. And this contract falls back to an off-chain resolver. So here is the code. If I check this, this is the URL. This is a backend from Scaffold-Eth 2 that will resolve the subname from the lugis.eth ENS. So I built this off-chain resolver using Scaffold-Eth 2 that the name are saved on Redis key value store. And then I built this website where any BuidlGuidl member can claim a Lugis ENS name. So the user can connect a wallet. And the website will check if the address is a BuidlGuidl member, and if this is a BuidlGuidl member, the user can claim ENS.
How are you checking if it's a BuidlGuidl member?
I'm using the JSON file that is returned from the BuidlGuidl backend.
Awesome.
BuidlGuidl website backend. I'm signing a request. Can you see the MetaMask? No.
Nope.
Okay, I'm signing a message, and I get the confetti. And now I can use this in any place that an address can. Here, for example, I can enter Damu that is, and if word, it will resort to my address. This is a result of doing that is done off chain.
Very cool. So you deployed a smart contract that is like a custom resolver, and that custom resolver points to just a server, and then you let people sign a message with their account, and that lets you prove that they're in the build guild. And then with that signed message, you set up an ENS address for them on the server. And so it's basically a free way to get an ENS name that, this is really nice onboarding because they can have a name and they can do stuff with their name. And then when they're ready, they could even go register a new ENS and like pay for it. But this is like a way to do like free onboarding into kind of Web3 using this kind of off-chain ENS at first. Very cool.
Yeah, exactly. We can maybe link in the speedrun Ethereum when the user finishes some challenges and let the user know that now he can claim a free ENS name from here.
Awesome. Cool stuff. Good builds,
Thank
Damu.
you.
I had one question about the randomness. Sorry, we're taking a long time and we got to hurry up. We got a lot of presentations to go. But there is this question in my mind about how a validator can refuse to mine a block. If this was a lottery and we're using future block difficulty, is there some problem where if the validator doesn't turn in a block on that slot, does something bad happen? Or is there a way that the system like works around that some way?
I'm not really sure, but the way that this works is like the random hash for each block is built by all the block proposer. So I don't know. It's hard to I don't get the word to
Español.
to trick the attack,
To manipulate, maybe?
Manipulate. So because no only one block proposer have the power to set this random. So I think that it's really hard. Here, I will share 1 second the screen.
Another thing is also block that 256 block window is going to be different on different chains depending on how fast those blocks are coming. For instance, on Optimism, I feel like every block or every transaction is a block. So if you did some commit reveal and you needed the block hash, you may be limited to only a few minutes to turn your thing in before you lose it. So there's a lot of like interesting gotchas.
I'm not sure how it works in Optimism, for example. I don't know, but here is this API that have some information about this randomness. Here is some security consideration that talk about maybe this kind of thing that you are talking about. Is a good read.
Cool. Okay, we can check that out later. We should pass it on to Coderxyz though, and keep going.
Yeah.
Good builds,
sorry
Thank you.
to take too much time.
Those are awesome builds. Very like highly technical. Very cool. Okay, how about Coderxyz? Are you ready? And then Miles is up next.
Oh yes. Let me share the screen and let me know if you can see the screen. Nice. So
looks like we got a doc.
Yes. Okay. So for this build, I went for a game, like very simple game. I call it PetType Quest, and it's a typing game with the pet feeding concept. Basically, suppose that you want to become a faster typer, and you come to this application, you set up the game, you create an account, and then you select your pet and you name it, and then initially, so initially it's gonna be like this: you connect your wallet, you select a pet that you would like to have. In this case, I'm just gonna do the first one, and then I'm gonna call it Amuse. And then when I click save, I already saved this one for the purpose of the demo. So it's this one. It starts with it will have three moods or three different status. The cat, in this case the cat. So this is the name, and then it says that your pet has a life cycle, and it requires 24 hours. It requires 120 calories per day. If you don't feed your pet within, or if you don't type, or you don't go back to this app and type, it will die. It's basically like a digital pet that allows you to, I guess, to master or hone your skills, your typing skills. And then it has some general information and the current status. So when you create a pet, it will give you like 20 calories by default, and then so this is good for this amount of hours. And then right now, I think so if we change it, so for this purpose, we can come here and play the game. And then let me just close the controls here so I can see so you come here and then select the level of the time. In this case, let's just do the 10 seconds, and then you can start the game. Then as you type, it will calculate the speed here, number of speed here, and then also at the end of the game, you can save your score. When you save your score, it will add it into your amount of calories. So let's just save it. For this demo, I think I save it to 10 or to 1. Let's just check. I save it to the status. I set the score to 1, so it should be like 22 right now. But let's just suppose that I change it. This should be, I change it to, and then as you change it here, it will change it to the next mood or the next status of the cat. So suppose that if we have like maybe more than let's say more than 90, that should change the image of the cat. So let's just see if it changes, and then yeah, so let's just okay, so I need to call the contract. So right now we have 92. I'm just gonna call it with another I guess 79 to be less than 100. Less than 100, maybe less than 100, yes. So we can see the change in the so we can see the change. So let's just call it with 65. We call the contract, we sign the contract, and then we should see that I'm not sure, it didn't work. The calories should change, but for some reason I don't think it worked. Yes, this is this one. Not sure what happened, but yeah, this should change it. Number of calories. It didn't work. Something went wrong. I think I changed the contract at the last minute, but yeah, this should work. But anyway, this I'm just gonna try one more time and see if it works. So no, it didn't work. But yeah, this should be, yeah, this actually is 93 now, and the image should change, but it didn't change. Maybe I need more. I forgot what was the number. Let's just put another, I guess, another 10, and let's just see if it changes. So let's just sign it, and then this application will allow you to, yes, very good. So this is when the cat has less than 120, the cat will be confused. In this case, like it doesn't know if it will have enough calories to make it into the next day, and if it has more than 120, it will become happy. So let's just do that. Let's just add another one. So yeah, now you have a happy cat, and then it will tell you here, and that's pretty much the game. So you can just come here, type your game, gamify your game, and then that's basically your pet. And then I use like a simple contract for this, and the Scaffold-Eth for the front end. Yeah.
Nice. So it's a on-chain cat that you feed by doing typing challenges. Is that right?
Right.
Nice. And it's on-chain metadata changes depending on how many calories it has.
Yes. So my
Cool.
time I run my end goal was to also to work with the block time, the time block time, but I run out of time. It's supposed to change also the time based on the calories. I need to come up with a formula that calculates the available calories, and that saves into the contract here. And then it basically tells you the calories, the amount of calories that you have, and based on the calories available, that will be the time left or the life cycle of your pet. And then if you
This
don't
brings
feed
up
it,
a
it will,
really good challenge in building blockchain applications is your pet can't just die if it doesn't have enough calories. Someone has to poke it, right? There's
right,
almost like this
exactly.
liquidation process that has to happen where everyone is watching all the cats. And whenever a cat gets low on calories, someone has to liquidate the cat basically and make a function call.
Right.
Is that kind of how this works, or how does it die?
I would like to do that too. Like basically like community. Anyone in the community can pitch to add calories to the cat, and then it's up to the calories to don't let it die. Something
There you
like
go.
that.
You could save the cat too, not just
Right.
liquidate it. Even
Right.
better.
Right.
All right. Good bill.
Yeah. Thanks.
Yeah. Miles, you're up next, and then Rohan is on deck. Miles, are you out there?
I'm here. Can you hear me?
Yeah, we got you.
All right, great. Let's see if I can share my screen. Can you see all that?
Not yet. Word's over here liquidating cats.
Okay, how about this? Oh, here we go.
There we go. Now we've got
Maybe the
Zoom. Yep.
Yeah, maybe the button that says share. That would help. Okay. So this is a fork of the Build Guild. And basically it's like a funding mechanism for musicians. So I'll just kind of like run through this. But basically the thesis is like distribution and production of music is so easy and quick. Like we've all seen like how rapidly it changed. But there's no like financial like startup capital for musicians, right? They kind of just have to bootstrap it. They can't get a bad record deal even if they wanted one, right? So how do we kind of patch the music kind of situation that we have today? I think a lot of people want to give money to musicians, and so I'm trying to kind of bridge some blockchain folks with some musician loving folks, and we'll see what happens there. So just gonna onboard someone. So we'll just walk through like an onboarding process, pretend like I'm a musician, right? So to start, you can just join. You can't be a musician right off the bat. You're joining as a fan. And so there is a whitelisting process. So go ahead and join. And if you're familiar with Build Guild, a lot of stuff is going to look really familiar, obviously.
Carlos is on the call. He built most of this, where you're basically making signatures in the front end, and those signatures are, going back to a back end where we can prove that the signature is true. It's kind of like a log. You log into Build Guild with just a signature, but we don't serve you the content unless you sign from an account that's like allowed to get that content, basically.
Right. So if anybody else is watching and want to know about signatures, look into this repo. It's like, yeah, if you can reverse engineer it, you will learn a lot. So this person signed up. They're just a fan right now. So we're going to use the admin account to go ahead and whitelist them as a musician. So I've got a bunch of leftover stuff here from the Build Guild repo. Just kind of adding in the kind of the basic necessary things that I'm trying to imagine. So yeah, we want to, I don't have all the messages updated yet. It still says builder, but they're going to be an artist. All right, so we whitelisted them. We're going to change it back to the other account. Cool, they're now an artist. They got kind of like a new UI. So to start, they need to deploy a smart contract. So the smart contracts are 1155 contracts. And I've set up a, let's see, we'll go into the contracts here. All right, so this is like a beacon proxy kind of setup. So there's the implementation contract, right? This is like where all the code is going to be called to. There's a beacon and there's a factory. So we're going to call to the factory to create a new contract. And so there's a payment splitter set up in this. So this is like a rev share model. The artist isn't paying anything to do a contract. They're just promising to pay out a portion of the money that they're receiving from people who are donating to them. So this is pulling from the smart contract, what that is. So that's changeable over time. And those numbers are locked into each musician or artist's contract. So it doesn't change. We're not going to kind of rug pull them and change the number on them later, right? So people who are coming into this earlier will have like a lower rate, and that rate I think will go over time. So it's kind of an incentive to onboard into the system earlier than later. So don't wait too long. If you're interested, get going on this. Okay, so they deployed their smart contract. Now they can manage it. So we got all the UI showing. There's their smart contract address here, and they're the owner of it. They're deployed. And so now how do people donate to this? We're using like an NFT. Like I said, it's an 1155 contract. So what's fun about this is that there's no like predefined limit of how many tokens we're generating for people to purchase, not really purchase. They're making donations and they're getting a receipt is really kind of how I'm looking at this. And so rather than using like an ERC 721 where you're predefining, hey, there's 10,000 tokens here and you're either in or you're out, this is more like a timeline. It's flexible and it can be changed for kind of each musician's use case. So what they first need to do is create a token for people to receive. So they're going to upload an image. I've been using this Miles Davis image, and I'm going to use like a really dramatic number just so we can see those numbers really easily. So we're going to be uploading to IPFS. We're going to be hosting that image for them on IPFS. We're going to make this transaction, and in our backend, we're uploading to IPFS. We're getting the hash. We're setting all that stuff in the smart contract. And then if I'm not hot reloading here yet, so something to add to the repo. But now they are active. So someone can come in and donate to them, receive this NFT as like a proof of donation. And so they're kind of proving like, hey, I like this band. I heard about them. I gave them some money because I want to see them continue to grow. And I've got this NFT showing my support, showing like, hey, I'm a fan. I'm kind of in their fan club. So we can go ahead and walk through someone else donating to them or receiving this NFT. So this person is not onboarded yet. So we're going to have to onboard them. So this is the musicians page. And so very rudimentary, but they want to join the fan club. We can see that it's $100 to support them. It's pulling from the smart contract. And so they're going to support them. I'm going to sign that. All right. And then, so the smart contract is holding the funds, right? And the payment splitter is doing the splitting of how much funds the artist is actually going to receive. So we're going to need to go in there and pull those funds out of the smart contract. So let's navigate back to their page. So the UI updated, we can see that there are funds in there. And so they're receiving 90%. Those are just arbitrary numbers we're throwing in there to make the math easy. But so then they're going to go ahead and decide to release the funds, pull that money out of the smart contract. Gonna go ahead and sign. And if we look at our MetaMask, should be able to see, yeah, we pulled out the funds from the smart contract. So that's kind of like very rudimentary of what we're doing here. The idea to move forward is for the musicians to then be able to give back to the artists that have supported them. as well as like we can differentiate the fans of the musician by like a time base. So let's say like a couple months goes by, they can go ahead and create a new generation of a token. So I'm just going to throw something random in there. Maybe it's less, maybe it's more to support them. I don't know. It's up to them what they want to do here. All right, I'm just going to refresh the page because I don't have that built-in functionality yet. So now it's a current generation. If you missed the first round of supporting the artists, now there's sort of like this incentivization to support them earlier than later. Like, don't sleep on it. You know, if you like these guys, go ahead and support them because there's going to be like a change over time, and they're going to be able to capture who their fans are, and they're going to be able to hopefully maybe return some support back to them or give thanks back to them. Maybe it's like a special pressing of a vinyl or something that, you know, only their fans are getting, or maybe it's a ticket, right? There's like ticketing services that we can add on to this. So there's a whole lot of things to kind of add on to this, but it's sort of to bridge the relationship of like musicians and the fans and try to reduce the intermediaries in there. So that's it.
Cool. Good build. Yeah, that BuidlGuidl backend is great for forking if you want to make like a signature-based system where you do a lot of stuff off-chain and just solve it and prove it in your backend. But then you even brought in some smart contracts here where you almost are like escrowing and doing payment splitting within the smart contract. Nice build. All right.
Yeah.
Up next is Rohan. We're going to go over time. I really apologize, y'all. If you're down to stick around, I'm down to stick around. If you guys want to go another maybe 30 minutes or so, I think we might. If not, we can go till next week too. If you have to drop, let us know and we can make sure we get you in first next time. But Rohan, you're up next if you're ready. And then Matt is next after Rohan. I don't know if I see Rohan. Is he gone? We might have missed him. I think we did. Yeah, I think Matt, you are up next, and then Port. I also don't see Port. We may. Yep, we can hear.
All right. I put the link in the chat to my build. It's actually a game, so if you want to get in, you can join.
Nice. I'm in.
You're seeing this, right? Or the like my mouse right screen.
Yeah, we see Vaults of Fortune. We kind of see two different windows here.
So this is like the landing page. So when you enter the contest, there'll be an enter button right here. It's going to airdrop you 10,000 gold tokens, and then you can deposit your tokens into the vaults, which are the ERC-4626. And then the Chainlink VRF actually determines the outcome. I'll trigger it first and explain because the VRF can take up to 5 minutes. But once you're all in. So you're gonna want to approve everything quickly. Would be my recommendation. I have it set for the infinite, which is like not best practice, but for the game it's useful, and we're on a test net, so it's not like you're at risk. So once all the vaults are approved, you're going to be able to deposit using the slider. The slider works for the most part. If you get into bugs, you might have to refresh the page. I have it set up so you can try to deposit into multiple vaults during this at the same time, but you might run into bugs. Right now, I'm calling the part that ends the round. Right here, only owner can do it. This is stuff that I'm still working on figuring out for how the game's going to run by automation. I had it set up with a 5-minute timer, but I ran into this problem with this build. Okay, yeah. So round closing soon. That means I triggered the VRF request. So now we're just waiting for it to come back. So we can kind of watch it here and see how long it takes to come back. But I ran into a problem with this build where I was actually reading too much and I just blew way past like the limits of the free alchemy API key. So I kind of had to simplify a little bit and like pull out a bunch of I had like a dozen event subscribers and a bunch of like event history, and it was just too much. So I simplified it down, and hopefully the VRF is going to give us a little response here, pending for 41 seconds. I'll explain what's going on behind the scenes with the code while that's happening. So the fulfill random words looks at each vault, and to manage the vault, you take the maximum potential ROI that can come back and the min ROI, and then you modulo the big number down, and then you do the percentage, and I'm converting back and forth between you and a bunch of times. And eventually it's going to either send gold to the vault, transfer it directly, or it's on the vault contract going to call simulate loss, which actually just transfers from the vault to the market contract that kind of controls everything. I'm a little nervous because I have a loop in the fulfill random words that loops over all the players to emit the events, because I was trying to read all of these with a hook that pulled the players array down and then read like your balance in each vault plus the gold balance you're holding on the side. I'm also a little nervous that it might just be blowing through the max limit for calls. Let's see if the browser is. No, it looks like it's okay. Get that out of the way. Are people?
I don't totally understand yet. There's the different vaults and the different amounts of risk, and you get some basically some fake tokens, some godel. You put the gold in, and then how do the different are there basically like fake tokens back behind the scenes that are kind of fluctuating? Is that what's happening?
So the only token that's in this game is the gold token, which is the basic ERC20, and I mint 1 billion of them, and I send it to this market contract that controls everything. Like it has the rounds and the contests, and I'm minting a bunch of events and stuff like that. And when you deposit, you're throwing your gold tokens into the vaults, and then at the end of the round, the VRF is going to trigger some logic in the fulfillment that either transfers tokens to the vault from the market contract, which has 1 billion, or it's going to pull them out by calling the simulate loss, which the market contract owns the vault contract. So only the market contract can simulate the loss and pull gold out of the vaults.
Got it. Okay, so it's almost like we're rolling the dice. We're taking our game token, we're locking it up in low, medium, or high risk, and then we're rolling the dice. And if you're in high risk, you have a high chance of winning. If you're in low risk, you have a low chance of winning, but also chance of losing too. Am I thinking of it correctly?
Yeah, so your potential is like, if you put your gold in here, you could potentially get 100% at the end of the round or negative 100%. Anywhere in between that is possible. And the same is true for the other vaults too. And I kind of like had this game theory idea where like, okay, so it came back at end of rounds, like the low risk returned 9%, the medium risk took 42% of your assets, and the high risk was down 13%. So like, if you got into the vaults in time, you can see it was adjusted. The people who got in all lost because I guess nobody put most of their gold in the low risk.
I went high risk.
The people winning are actually
the no players.
The no players. But
cool.
Yeah, I thought there was like also a little bit of game theory where like if everybody was in the high risk vault, you want to stay out of that and hope that they take the big negative, and then you're up ahead for the next round.
Very cool.
But yeah.
The fun thing about this is it's using a bunch of existing technology, like VRF is something you're going to use for randomness on a mainnet application, right? And these vaults are this nice generalized way to have money invested in a thing that you can harvest and like withdraw and deposit. You also use some good AI art too. It looks like you did some Dolly or some Midjourney here too.
Yeah, GPT-4.
Yeah, very cool. Yep. Awesome. Great build.
Sure. Thanks.
All right, I think Shiv is up next. And then Keshav.
Oh,
wait, is Port there? Maybe Port is here. Yeah. I'm sorry. Port is here. We've got Port. Yeah. Let's let Port go if he's here. We'll go Port first and then Shiv, if that's okay.
All right, thank you. So let me share my screen real quick.
He's the learner.
Yeah, why am I learner instead of Paul? No. Yeah, so
Just learning more.
yeah.
Always learning.
So you probably have seen this before on Twitter because it got plenty of views, but here's what I built last week. So where is it? This is kind of an ABI ninja, but very, very simpler. So what this does is basically it reads a contract from the Ether scan or what? All right. So it decompiles the ABI and it does it using the heimdall-rs from John Beckham. Where is he? Yeah, this guy. Shout out to him. He's a great builder. So this app uses a simple Rust backend to as an API. So the app can call to this API to decompile the ABI. It returns the ABI. Then we can just use Scaffold-Eth's standard, user interfaces to give us a place to interact with the said contract without providing the ABI ourselves. So you get the ABI and a couple of fields, and these are the app does not know what these are, so it just shows some possible values instead of just one. So I will probably put this on the internet as a website, but I'm having some problems with how I structure my Docker file. So as soon as I figure this out, as soon as I figure how this works out, we can integrate this into ABI Ninja as an experimental button. So we currently have two tabs here: verified contract address and address plus ABI. Maybe we can have a little, decompile ABI, parentheses, experimental or something. So I think this will be extremely useful. And also call to Rust chats if you know how to deal with Docker files or Rust in general. Please send me a DM on Telegram or Twitter or wherever so that we can figure out how this is not working. The Rust code is pretty simple. It's very short, but the Docker file is giving me some troubles.
Yeah, I'd love to see that
so simple.
implemented into ABI Ninja. That would be great. Maybe even not another tab, but you just kind of paste in the address and it goes to Etherscan, and if it can find it, it loads it right away. And if not, it says it can't find the ABI. Do you want to upload it or try to calculate it? And you hit calculate or something like that, and it takes you to kind of your stuff and figures out the function calls. Nice build, Port.
Oh, yeah.
If anybody knows Docker well, is it Docker or Rust? Combination of Docker and Rust?
I think I think my Rust code is fine because it works locally, but it doesn't work when I push it to Fly.io or Google Cloud Run. So the problem is Docker, I guess.
Yeah, if you know Docker well, hit up Port. Let's see if we can get a ABI Ninja that works without the ABI. And then it's just a ninja, I guess.
Oh.
Yeah. Okay, now Shiv. Now Shiv is up. Thank you, Port. Good build. I look forward to seeing that thing go to production. And Shiv is up. All right, we got code. Oh, back to me. No, go ahead, Shiv.
Yeah. So basically, sharing a couple of builds which I built at Istanbul. So these we built at Hack Zuzalu. And we also won the first prize from Zuzalu Infrastructure Pack. So basically, how this works is those who have attended DevConnect, they should have known the ZuPass.org. So basically, it holds tickets, and these tickets are basically ZK proofs, ZK tickets. So you can turn the ZK mode on and just prove that I hold the ticket for this event without revealing your email and name if you want. So currently, how this ZuPass.org works is you see these folders these folders are basically just added by the ZuPass team, and there was no currently proper way to add your thing in this ZuPass thing. So basically, we build something similar to add your tickets in the ZuPass. So basically, what we build is, let me show. So basically, what we build is like you can prove the ownership of an NFT and without revealing your address. So basically, you can prove that you own an NFT without revealing your public address, and the event verifier can verify that yeah, you own the NFT without revealing your address. So yeah, let me start the demo. So you connect the wallet.
And we
So
tried to
once
make
I
a
connected
ZuPass
to-
starter kit too. You didn't use the ZuPass starter
Yeah.
kit, did you?
No, this
Okay.
is a bit different. Yeah, I'll share the difference now. So you get the proof. So basically, here you are getting the proof from zupass.org, and basically this proof is basically a signature PCD proof. So you just prove this, and then it will again take you to yeah. And then you need to sign a message now, and this I will get to the code again. Once you sign the message, then you choose the NFT which you need to prove that you are the holder of this NFT. So let me choose the merge NFT. Once you get this subscription URL, you just copy this and go to zupass.org, their website, and paste this subscription URL here. And once you paste this URL, it will say subscribe. And once you go to the main page of the zupass.org, you see, right? Here it added a new folder, the merge. And basically, this ticket basically denotes that you hold this NFT and you can turn this ZK mode off on and just prove that you are the owner of this NFT without revealing your address. And here you can see the public key which signed. So basically uh, here we have two things, the front end and the back end. So let me show you the front. So basically, let me show you how this works, like the flow, how it works. Yeah. So basically, first we connected the Ethereum wallet, then we signed a message through ZuPass. So basically, we created a semaphore signature PCD, and then we sign a message, then we create a token. So basically, we create this JWT token kind of a stuff, which is base 64 encoded, and then we generate this link. And when you so you saw, right, in the ZuPass, I added a link here, which I got from the front end. The new subscription, I added a link here, which I got from the front end. So basically, this link is hitting a backend which does all the checks, like whether you hold this NFT or not. So this is the thing which you need to hit to add a ticket to the ZuPass. So the ZuPass guys will hit this URL, and this backend checks all the stuff, like it recovers the address which signed the message. It recovers that it was signed by ZuPass Semaphore PCD package. And yeah, I mean, then it checks whether you really own the NFT. And if you own the NFT, then only it adds the thing in your ZuPass. So if you don't own the NFT, you won't see this thing. And yeah, and on the front end, like you can go, and also if there is another system which want to verify that whether you own this NFT, and you don't want to, let me show you. So they consider this as a different front end which want to gauge that whether you hold an NFT, and you want to prove that system that you own this NFT without revealing your public address. So you can just get the proof from ZuPass, and it will ask the ZuPass for the ticket, and you can just prove this, and they can verify it on front end. Yeah, just click the proof has been verified. Yeah, and another project, just to give a glimpse of this, we built at ETH Istanbul. And if anyone wants to look into CCIP, like I would highly recommend this. Like if you want to do cross-chain stuff, like you can go through this repo. It's really nicely built, and even the front end is also a cross-chain, so you can connect any of these chains. So basically, write happens on any of the chain, and read happens from the main chain, which is optimism for this. Yeah, that's it.
What's it using for the cross-chain messaging?
CCIP, Chainlink CCIP.
CCIP. Okay, cool. Very cool.
Yeah,
So good
yeah,
ZuPass
yeah.
integration and different CCIP integration. You guys,
Yeah.
you were busy in Turkey. Okay, up next is Keshav, is that right? And then Codechef and Hacklight if he's here.
I'm
You're
audible,
up.
right?
We've got you. Yep.
I will quickly share my screen.
We've got it.
So,
End of round. You were gambling too.
yeah.
Should have gone low risk. Should have gone go low risk.
So this is what I built for the backdrop build. So I had an idea for ETH Online, but I didn't have enough time to build it completely. So I shifted that idea, and I was really going through the whole ERC 6551 and thought of building this on backdrop build using Scaffold-Eth. So so that's what I built. So we will first quickly mint a Stevey Wonder here for ourselves. So what this will do is it will create an NFT and it will create an account out of it as well at the same time. So if we go here in Stevey Wonder, whenever I mint a particular NFT, it will create a token bound address for it as well. So which will have so this particular NFT is address will be a TBA address, and if you do TBA dot, although I can't do this here because I have to add one more thing, and I didn't had enough time to create the front end for everything, so it's still a very great mess, which I will try to figure out in this week, and I will show the updates in the next week. But what the main thing is here is this account is just a source code or a factory contract for all the account implementations which are going to be used by this ERC 6551 registry, where you just add this particular account address, and that's how the whole thing goes. This can be easily used as a cross-chain thing as well, but because the way the ERC 6551 EIPs has built out, they really want to give the NFT more liveliness so that you can make NFTs more useful and things. So we will quickly mint a t-shirt here. So here my token ID is 2, so I will quickly mint token ID here, save mint for the 2. So what I'm doing here is I will mint for the token ID of Stevie Wonder 2. That you don't have to mint for a particular address and send it, but you can just mint it for the token, and whoever owns that particular this token ID, then he can get it. Then we will I can do the same for all the shoes, pants, and glasses as well. So let's do that quickly as well, and I will show you the end result as a so here are the pants. So again, save mint. Glasses. So it's a very redundant thing, but the whole point of this is that to give a really good composable thing. I really read a lot about logis and fancy logis and various different logis to just understand how Damu has done all those things. I was really fascinated when I started to read your EIPs which you published, which was 4883, I guess, for the composability of NFTs. So that's how I got to know about all the NFT things better because I've not built much NFTs before. So once these all goes through, then we should see some clothes on this guy. I'm doing it correctly. Okay, now we have minted it for him. Now what we have to do is we have to uh, make him wear them as well, right? So I will quickly do that as well. About to do that. Copy this address, set active accessory for this particular token, and the accessory should be 2, I guess.
And I'm not sure if you've mentioned it yet, but because of the 6551, you can get this guy all composed and dressed up, and then you can just send him from one person to another,
Yeah,
like an
yeah, I
NFT,
can
and then
just
they
send
own
them.
the whole thing. Yeah.
Yeah. The whole point. So like here, I made him active here, and he is wearing a t-shirt now. The whole point of it was to first really build very simple Stevie Wonder, and then give him a good attire, and then create a wardrobe for him. So it will be like a RPG, like yesterday in the chat, someone said, I forgot the name, but uh, yeah, Pablo said it that we can really create a great RPG character out of it, and we can use it as we can create an indexer out of it, and I don't know what I'm going to do out of it, but yeah, it's something that I wanted to build, and when this character was wearing clothes, I was really happy.
It doesn't,
That
not everything you ship has to go to mainnet and, get
yeah,
100,000 users, right? A
definitely.
lot of the things you have to
Yeah.
build, you build along the way to learn how to build them. And it's okay to put things on the shelf and move on to the next thing and keep building things. So don't be too worried
Definitely.
about the full point of this. I'm glad Stevie Wonder has clothes on too. That's good.
So I am giving him some shoes now. So you can just the great part about this is which I was able to figure out that even if he has worn this cloth now, if so the only problem here is I have to create some kind of interface here or here to so that you can use your smart contract wallet which you have created out of this NFT so that you can send them as well, and you can do trades with it and do different things with it, whatever you want to do. If I want your clothes and you want mine, then we can just trade them. What in whatever wardrobe you have or I have. So I have it's something like a Steam trade link if you know how CS:GO skins get traded. So something like that, but for clothes.
Yep, exactly. And
So
so this 6551 isn't only going to hold the tokens that you've created, the clothing tokens and the crafting tokens. You could also send it DAI and USDC and any other
yeah,
token.
definitely.
And
Yeah,
with the way the
definitely.
token standard works is like this character right here is going to have its own contract address that you can send things to. And then if you own this character, you can move those assets in and out of the character, which is really cool
Yeah.
because you can get him all dressed up. You can give him a bunch of dye, and then you could sell him to someone else on OpenSea or something like that. All of these standards working together. Very cool.
Yeah, yeah, definitely. So it's just a small start which I wanted to present because it's my first presentation in BuidlGuidl, and I was the one of the cohort members when you started that BuidlGuidl cohort in last year in August. So that's when I started my build journey by doing the speed run, joining your cohorts, learning basic things about Ethereum, and then I went off track, participated in various hackathons and developer DAO, and then I came back here and I built this. I'm very happy.
Awesome. Good build. And it's definitely not off track to be going to Developer DAO and to be attending hackathons and everything. Keep doing that too. I mean, we're glad to have you back building here, but any building in the ecosystem is good. Keep creating things. Keep using Scaffold-Eth. That's a great forkable build. Keep going,
Yeah,
Keshav.
definitely.
Good build.
For a guy
Awesome.
like me, scaffold is a blessing because I don't like front end much.
Yeah,
I'm kind of a back
it's a lot
end
of
guy,
work.
so
Yeah.
this is really a saver.
Yes. Yes, this debug interface is very powerful for sure when you're building it.
Definitely.
Yep. Shout out to the Scaffold-Eth team. They're on the call. Okay, last builder. I think it's Codechef. I bet Codechef may have something that uses a 6551 also. He does a lot of game and composability and stuff like that. Keshav, I think you're still sharing if you want to close the share
Yeah.
out, and then Codechef can take over. I could even steal the screen for, oh, you got it. Okay, Codechef. Sorry we are so late. Thank you all for sticking around. We got one more to go. Let's
Okay.
see what Codechef has for us.
Okay, hi everyone. So now I'll share my screen. We build like a simple game. So I build like a hot potato where you need to beat the last player remaining without the hot potatoes. Oh, give me 1 minute, sorry.
All good. Very cool. So it looks like I see the potato there. 817 has it, and he's probably going to pass it around from person to person.
Oh, sorry about that.
Yep, go ahead.
Oh yeah, so I built a game called Hot Potato where the objective is to be the last player remaining while the hot potato with the game ends. So and to play you can click on the play button, it will take to the lobbies. Is it working? Oops. That's strange. Okay, I didn't see the problem. Go to lobbies and then you can create a match. You can join, and then for the second player, you can also join. And oh, there it is. So I'm using the bot height for the timer. So similar to the music for the traditional hot potato, when the music ends, and for the person that hosts a hot potato, you'll be eliminated. So you can like click on pass, and this will start the timer. And is it working? That kind of works. So yeah, just like keep passing it, and then you do not want to be the person holding the hot potato, otherwise you will be eliminated. And pretty simple. And originally I was going to use the price of the ETH and then use the chaining price fee, but that might take time because the price of the ETH is it's very unpredictable. It might take 1 day or may take 1 month to reach a certain amount of the price ETH. So yeah, I've been eliminated.
Cool build.
Yeah,
I could see bots being important here. I think with all of these on-chain games and composability and it's all deterministic and public, there's always going to be bots playing this. And I could see this one, like you write your bot to just make sure it's never holding the potato if you can. And when it lands, you send it as soon as you can or something like that. Or maybe it's more strategic, but cool build.
Yes, it'll be interesting if I deploy this on mainnet, because now you have to like time it and you can't just like keep passing because it's gonna be expensive on
yeah, maybe not
capacity.
mainnet, but maybe like an L2 or something like that has, continuous blocks and the timing is right. But maybe even on Optimism where there's a sequencer and you can't front run or something like that. I feel like front running could be interesting here, where you could flood the mempool with a higher gas transaction. I don't even know. I don't know how to attack this yet, but I think you could attack it in some fun ways. But cool build.
Thank you.
Yep. Neat. And again, like Codechef does games almost every other week. And one key thing that we're seeing is like this, the waiting room, right? The way that you orchestrate a game, you kind of have to get everybody together and maybe get them to stake. And then once everybody's staked, then you move into a game round. And I see a product kind of developing there. I wonder if there is some product around waiting rooms for games, or some kind of allow you to bet. I think last week we had someone do something similar. I think Damu, maybe you did that, like a betting room where you can bet on some on-chain variable and get everybody together around that as a second separate product. Cool builds. Great Bowtie Friday. Definitely, this is the longest Bowtie Friday in history. We went in a full hour and a half. Thank you for all the presenters. Thank you for all the chillers hanging out, supporting. Any last words before we go? All right, hearts. Happy Bowtie Friday. Thank you guys for coming out. See you in a couple weeks. Let's do this again. See y'all later. Thank you.